My name is Greg Grieves. I'm a DevOps engineer from Nexidia NICE. And this is my colleague, Jim Watson.
Hi, everybody. Thanks for being here this morning. My name is Jim Watson. Again, our talk is on applying cloud tools in our legacy environment. And Greg's going to go through kind of who NICE Nexidia is, what we do as a business, and what we offer. And then I'm going to kind of tell you guys what our challenges are, what our environment looks like, and we're going to go from there and show you guys what we kind of use Salt to tackle within a legacy cloud environment.
Thanks, Jim. All right, so we are in the business of primarily voice analytics, but also other types of interactions, including social media, text, video, and so forth. The idea spun off from a research project at Georgia Tech doing signal processing in an electrical engineering lab. The core technology allows us to perform direct audio search. It's sort of the inverse of speech recognition. But the technique is unique, and it allows us unprecedented level of accuracy and scale for large-scale search. As you can imagine, this industry is booming right now. It has broad applicability across almost any industry. We have an enormous variety of different customers and use cases. Any business that has a contact center or support division, legal customers looking for discovery, regulatory, military and government intelligence, and media. In fact, our company actually has an Emmy Award for the accuracy and real-time transcription services for providing closed captioning. Nexidia owns 100% of its core technology and the application. We employ over a dozen different speech, language, and AI researchers, and we have over 21 patents and more pending. While we also offer on-premise systems, we also host our own private cloud. Due to the nature of the enormous volume of audio media, the high-resolution audio media, the different types of codecs that can be involved, sometimes one customer can have multiple different call recorders providing data to us at once. There's a huge amount of logistical complexity involved in that, so we offer hosting so that the customers themselves don't have to worry about that end of the deal. We are a entirely Windows and Microsoft SQL Server shop. So we are, as DevOps, we are in charge of ownership of that hosting solution. We provide dedicated tenant architecture. You may be able to imagine that across all these different industries that have interest in voice analytics, even within a specific sector, the different customers have different use cases and different demands, different types of information that they're interested in getting the analytics from. And so we tailor and customize our hosted systems for them. We have multiple single tenant environments, so the data is not shared across the network. Each environment is isolated. Because of the varied different use cases, we comply with most of the biggest security standards in the industry, and we have to apply those to every tenant, regardless of whether they're using healthcare or payment card information. We provide those levels of security to them across the entire environment. Our research started back in the late 90s, so we have over 20 years in the voice analytics business. From that, we've grown. We've had a lot of interaction. We've learned a lot from our customers and the extremely different use cases. I'm learning about new ones almost every day. And our team, our operations team, is a highly interdisciplinary and multidisciplinary team comprised of people from very different backgrounds. And in our organization, we work with a lot of overlap between the infrastructure operations, the support organization, the software development, and the customer services divisions.
Thanks, Greg. So I'm going to talk about kind of what our team is actually responsible for on a daily basis. We primarily partner with our infrastructure team. They actually call themselves the IT department to manage our hosted environment. We have 4 geographically distinct data centers with over 100 hosted individual unique customers and over 900 Windows servers. Our team is responsible for the day-to-day management and operational activities. Now, what that means for us is a little different than what I think it means, and it's a little bit different for everyone everywhere, right? Not only are we responsible for making sure the application is still running, we get over 1 million different audio files a day across all of our customers. And on top of that, we get metadata files associated with those that we have to match and process, and we have to assure that that processing occurs. It's not enough necessarily for our customers and our system because it's very transactional to assure that things are still flowing. Our customers expect that calls, recent calls that are coming into their call center, are available for their telecom teams to then analyze in their systems. I mean, they're paying people to sit there every day to make sure to catch problems in their call centers, and they demand that their calls be in there. So we have very tight thresholds where in a few hours we need to catch calls are not coming into the system and rectify that. Now, that's our core job role. On top of that, we're also responsible for any automation in the environment, which before Salt was basically Windows Task Scheduler. Not happy to say that. Yep. Yeah, that's anything from reports or whatever. We're also the developers of our own monitoring, the consumers of our monitoring, and the deployers of our monitoring. We have a NOC team, of course, that watches. We have a dashboard system that we have them monitor and roll things out for the support team. But we are both creating it, primarily Greg actually developing it, rolling it out, and then also consuming it all day long, every single day. On top of that, Greg and I specifically are responsible for change management in our environment. So that means every change control that comes in, we have to review it, approve it, deny it, qualify it, whatever we need to do. Of course, uptime availability, that goes with all operations. And then we offer a lot of canned reporting for our customers, but as it's a hosted environment and everyone wants their special report for something that they want to check, any custom reports come to us. We have to both develop and deploy those. So coming from that, we have a lot of challenges to operating in our environment and kind of try to paint the picture of what a legacy cloud means to us. We're all Windows, as we said, and it's all Microsoft SQL Server. And kind of going back to those 4 pillars we talked about, private cloud has a lot of challenges. We own all of our own hardware. We have to provision that. We have all of our virtual machines. Our environment is mostly bare metal. Due to the demands of phonetic indexing on media, the computational power, most of the time, even that layer of VMware is such a loss of computational power that we have to go bare metal. We have a lot of bare metal GPUs that we can throw into systems to actually supplement that as well. Because of that solution and how segmented all of our customers are, it makes it very difficult to keep an eye on what's going on. And something can be burning in one environment and one environment only, and you have to track that down. And that could be, everyone has lower priority customers or higher priority customers. Before we started using Salt, that was our life, right? It was, okay, a smoldering fire over here is something we might not be able to get to anytime soon, as opposed to maybe our biggest customers. Greg kind of touched on that single system, single tenant architecture means every customer is a snowflake for us, for sure. We offer a lot of different, with the audio indexing, with the recording systems, we offer a lot of different things like redaction. So if someone's calling in and giving a credit card number, they don't want their analyst to be able to search for that in the front end. So we have to be able to redact that. That's a feature we have to install. Obviously, not everyone's going to have that. There's stitching different segments of the call together. There's a lot of different stuff, and everyone's very different. Different recorders, different codecs. We have custom solutions for customers that go all the way from just 2 servers to over 90. Oh, actually over 100 now. And those customers that have 2 servers, those servers will be different. They will have different services installed, and they will have different use cases in those cases. We have no customer that's the same as any other customer. Also, our team is in a tricky position. We are a small team, 6 people, including our manager, and we're leveraged between 4 monolithic organizations: our infrastructure IT department, our global support organization, our global professional services or deployment services department, and also our huge global engineering department. So we don't have a lot of pull on anything. So we have to get as much as we need to get done by ourselves, and we can't really enforce standardization or uniformity at this time. Those 4 pillars obviously have overlapping responsibilities and roles, and also competing interests. So again, we have to deal with those challenges. On top of that, like any good engineering team does, we have our own tools that we've created, and deploying those is both painful, and updating them is also painful. Lastly, we have very specific security requirements. We have no Windows remote management. This is part of one of our security features, I guess you would call it. That means that remote management is extremely difficult. Before Salt, there was no remote management. We rolled out Logstash before we had Salt. I installed Logstash manually on every single server in our environment. I will never do that again. We have separate VLANs, of course, and physical servers for every single customer. Encrypted media drives, we have to encrypt all the media. And then dealing with encrypted media is painful, especially when you're talking about terabytes of encrypted data. And then, of course, we have offshore exempt customers. That's offshore relative to where our customers are located. We have North American customers that don't want any of our India guys working on their systems. Vice versa, we have customers in the UK and APAC that we can't log into.
So as Jim emphasized here, the complexity of our environment with no central automation scheme, how do we apply Windows operating system security patches? The infrastructure team is primarily responsible for making sure that Windows is kept up to date for security vulnerabilities. And this has to be done every 6 to 8 weeks throughout the year. In order to do this, Windows, to apply patches, of course, as you know, you have to reboot the entire machine, each machine, sometimes multiple times, to get successive patches to layer on top of each other. So this process requires a reboot of all approximately 900 servers over all 100 single-tenant environments. Our team is responsible for making sure not only that the customer user interface is restored properly, but that the back-end file transmission is restored, any backlog is caught up, any interruption is rectified so that the calls resume, that the calls are getting cataloged and categorized and sent to the correct servers for analysis, and that the data from those servers is coming back into the database and is accessible to the customer front end for doing the analytics and reporting. So we're responsible for a very complex system of interlocking steps. And we're under a strict time constraint. All the systems must be restored and working as designed within a 48-hour window. So what does this entail? Bringing a server back online and making sure the application is recovered doesn't always happen gracefully with Windows, right? We have, as Jim pointed out, we don't have dedicated server roles in our architecture. Different services can be located on different servers depending on resource availability. So the services are distributed across multiple different servers with no well-defined role, but they must be restarted in the correct order, which means we can't leverage any built-in dependency for the services. In other words, because certain services have to come online first, when the IT ops team brings the servers back online, they're literally just plugging them back in. They're coming back up in random orders, and this can lead to bad states where things that are expecting to talk to each other just can't. In addition to that, we have two distinct scenarios. We have a subset of systems that need to be preemptively shut down. Now, all the systems have to be stopped in a correct order, but the subset of systems also has to be handled a little more delicately due to increased risk of data corruption. So we need the services to stop in a certain order so that the data that's already in the system can continue to bleed through. Any data that's cached can be flushed to disk safely, and let all the activities in the database, ETL, come to a halt before we want to stop them so that we don't have data integrity issues. Then they need to be brought back online, but they can't be brought back until the final reboot of the system. So we can't leave them in automatic startup mode during this process, because otherwise the services will be trying to bring themselves back up while the server is being brought back down again, possibly 2, 3, or more times. So we have to set the services to be disabled in between these restart events. We need a system of record to, again, these because it's a legacy system, they're already built and designed. We're retrofitting Salt to handle this task. So we have to have Salt capture some sort of as-built information and use that to feed into the states so that the states know what the configuration was to be restored. And then finally, we also have an ever-changing list of customer exemptions related to, because the different business sectors, we have different times of year are busy for different clients, right? Tax season, holidays, shopping season, retailers. and so forth. The different sectors have different criteria, and so some of them need to be exempted from certain patching activities while they're in the middle of a big event that they need to capture the analytics for. So then we need to be able to handle those as well.
So this is what our actual Salt solution is. Now, I will admit that the technical challenge here, it wasn't necessarily restarting the services themselves, right? That's not really hard. The technical challenge is getting it to work across the entire environment successfully every time. You guys will see here at the end what we did before we had Salt to accomplish this, and compared to what we do now, it's pretty wild. So we just have a series of state files. I have 4 state files for each use case. The main use case is just to stop the automatic services on the box that we want to stop in order, and then again, start them across a series of states in order. The exception case, I actually have to create a YAML file in order to create that snapshot, that history of what the good state that I'm trying to restore to is. I then import that back in. Now I create that on each minion. I then import that back in with another state to stop them and set them to manual. We make sure we drain the system down. And then I have another 2 states that will go through and use that list to restore the system. Now for targeting, we have to, because we have so many exceptions and exemptions, we need very precise targeting. Now enterprise obviously allows you to create targets, but we use these JSON target lists so we get all the exact machines that we want to. This is just a big list of minion IDs actually. They're broken out of course by geographic region because we start at 3 p.m. on Friday and we do our APAC and UK customers, and we go all the way through to starting on 3 p.m. on Saturday to do our US stuff. And then we have exception cases where one customer needs to be restored in 3 hours, so that's how it goes. And these are regenerated every weekend. All of these get leveraged by a single orchestration state that takes inline pillar data. What it does is it takes which state file I'm going to run, and then what JSON target list, and I can also override it by providing an ad hoc list. So in the example, it doesn't make sense if I have one customer that has 3 servers to create a list for, and commit that, get that onto the master. That doesn't make sense. So I just override the minion list in the job itself. The big advantage this gives us, it gives us batching for performance. With our phonetic indexing, our Windows boxes are typically running at almost 100% CPU capacity. That means even responding to even Salt requests can take a little while. So by having we set the batch level about 15 in flight at a time. Yeah, that's a lot of servers and it takes a little while, but it also guarantees a high hit rate. In the end, I'm looking at about 5 services at a time maybe that have a problem. That's a lot easier to triage than like 100, because then you have to log into those boxes. And kind of in the last state here when I do the job, my process is I go to the job, I update the job, I run it, I change the target list, change the state, I run it, and I review the results. Now, when we have failures, we obviously deploy somebody out there to go look at it, or myself to go look at it. But when it's 5, that's not a lot, especially over 1,000 different servers. We review the results, move to the next step, rinse and repeat each time. Here I've got some examples of what my actual states look like, using, again, very generic, Jinja templating to go in there, get a list of all the services, find which ones that we actually want to use for our product, which are all of our Nexidia services. Go find which ones are automatic, and in this case, in our first picture here, just stop them, service.dead. Then I have pictures here of our 2 different stop states. I use require a lot, as not only do I need to make sure by breaking it out that certain services are up across the whole environment, I can get a couple to come up at the same, right after one after another. So use a lot of require state. Again, the last one, for example, here, just using our text grid system for our processing text interactions, goes through and has to start like six different services in order correctly. So. That's for our majority case. For our exception case, this is the one here where I'm going and I'm creating the YAML file locally on each minion with a list of the automatic services that we're looking for. I then have a series here of state files that go through and import that YAML file into itself, find specific services, and start them in the right orders that they need to be stopped and started, right? Stop, set to manual, start, set to automatic. Lastly here, I have examples of the orchestration job that I'm running. This is the one where the 3 inline pillar data things that it's expecting, variables it's expecting, just a quick little if statement that's saying if it's overridden or not. And then it's just running a target list type batch size 15 and a timeout Last is the screenshot, of course, from enterprise, in this case showing that I'm doing the stop for all services. I'm targeting the UK and our UK master cluster. So now Greg's going to show you kind of, guys, what we did before and what it looks like now.
Thanks. So as we kind of set up here, prior to this, it was an incredibly manual task. It required a lot of logging in to individual servers. It was a 30-plus consecutive hour effort with over 24 individual resources. Enormous level of pre-planning and coordination because of the exemptions, right? We had different resource availability on different weekends. We have different resources located in different centers around the globe that have restrictions for different data centers around the globe. So we had to come up with a complex matrix for assigning roles. Each customer had single tenant environment had to be logged into, and somebody had to walk through each of the components of the application to make sure that it was responding correctly and that it was populating with valid data. Each of the validators weren't necessarily support engineers, and so while they may have known how to test the system, they didn't necessarily know how to fix the system. So then we had a subset of these resources that would escalate issues to somebody who could. So there was a lot of crosstalk and communication. When issues were discovered, somebody had to be dispatched to go in, log into the server, track down what the source of the issue was, and rectify it. So you can see that with so much manual intervention, right, there was a great deal of variability and not necessarily a very high success rate because issues could have been overlooked or missed or not fixed correctly come Monday morning when the customer wants to resume their day-to-day activities. After SALT, this reduced to a 15-hour effort broken up over 2 days, which means you could actually get some sleep in between. So that's a 50% reduction in time. 5 ops team resources are involved, and the restarts are managed just by one single resource, Jim. So that is a 80% reduction in personnel required. SALT reliably restarts the services in the correct order, which ensures that the system comes back up in a good working state. We use SALT, the returns, as well as our monitoring dashboard in combination to identify any outlier issues, and then we can just dispatch specific individuals to those systems to troubleshoot and find what the issue was. So it's much more targeted. It reduces the amount of troubleshooting time because we know exactly which system, what component, and what server to go to look for the issue, rather than coming in and having to start an entire troubleshooting flowchart. So the speed of being able to rectify these issues increased dramatically. So this has been so successful that manual validation is no longer necessary. We have a high degree of confidence that come Monday morning when our customers log back in, it's as if nothing happened. Of course, this was just one example of a big success for us, but we have lots of other things that on our agenda that we want to try to accomplish and other successes that we've already accomplished. Jim mentioned the difficulty and complexity with rolling out our monitoring tools. Not only are we monitoring the servers, and the hardware, and the infrastructure, and the network, our application is highly data intensive. And so we have a lot of monitoring tools that are actually watching data flow through the database, making sure records are getting processed correctly. So we have a lot of custom SQL scripts that give us detailed information about the workflow inside the system. So now we're able to roll those out and deploy them across all systems and get unprecedented level of visibility into our applications.
Yeah. So, well, and on top of that, I mean, so we're not where everyone wants to be, right? Like, we don't have configuration management in our environment, right? Like, but now that we have SALT, we've actually have the ability to see if configuration changes are being made and have it monitored. So before that was something, people go in, we have a lot of people with admin access. They go in, they change something, a system breaks, we have no idea that it's changed. It could be days. Someone can change retention periods on things like that. We have no way of catching that sort of information. We don't have the ability to control it and revert it right now, but we've already gotten to the point where we at least have eyes on it. So that was a really big win in our environment. It seems small, but it's a light years ahead of where we were even 6 months ago. The other big thing that we did was it allowed the automation and deployment of our POC service for our sale. We have to sell our own systems, our own solutions to customers. It took about 30 days for a guy to go in and stand up those POC servers every time. We've got that down to 5 hours. That's installing a third-party big data business intelligence application, and then installing our the latest, the greatest 5 different pieces of our proprietary software. Whatever the latest GA release is, it has to get on there. We have to pre-populate the system with data and get that out. And then, that took 30 days for someone to do before. It's now 5 hours. And the big thing that Greg's really getting us going with is this accumulation of the existing configuration data. Now we actually know what versions all of our customers are on at any given time. Instead of having to log in, we just have a little dashboard for it. Seems small, but we didn't have it before. This oversight allows us to begin the process to transition to infrastructure as code, which is a complete impossibility even 6 months ago. From that, Greg's already working on building templates on what our existing systems look like today to try to figure out what exactly is the best solution for our customers. Because everyone's different, the idea being, we have this approach, every customer is a snowflake. Well, I think we can probably narrow down what that solution looks like. But once we know what we have out there deployed today, we'll be able to actually get there. Just have our list of acknowledgements. So I want to open up questions. Guys, anyone? In the back. Why do we use Windows? To be honest, I don't know. You probably know.
So we started off. We started off as a small company. It was a small business. It was spun off from academic research. They wanted to get to a place where they could spin up a proof of concept and develop a small business very quickly. Windows does allow you to do quick development, right? There's .NET and SQL Server allow you to get in there and get things built. But we are in the process of growing, right? And so we're experiencing the pains of growing to become a global organization and maturing from a small business mentality to a large business mentality. And so there's some scalability issues there that Salt is going to help us with.
Good answer. Is there?
What was the best way you found to get more people on your team with Salt? Courses or training or books to look at?
Good question. That was, what do we do to get more people trained up and interested in interacting with Salt on our team? Honestly, it was showing them the power, right? That's where it was the most success I found that we had. We have deployment engineers that actually deploy our product today, right? Like that's all they do. They install and configure the software. Showing them that POC system was like an earthquake for them. All of a sudden, we have a whole team that's like 20 guys that is very interested in automating. They're using like PowerShell tools, little ad hoc things, batch scripts, anything that they can do to get this stuff done. Seeing this system run from start to finish and provision a system, I thought was the most powerful way. In our company, we have a lot of people that have been there for a long time, and they've seen a lot of things come and go and not work. Showing them success is really the only way we've found that convinces some of these guys. We have a lot of PhDs. Greg's got a PhD. Smart guys. They like to see something work, and that was where we got the buy-in. And from there, it's been working with Rob back in the corner here, getting people trained and getting them to be excited about it. Another question? Yep.
You mentioned you guys deal with a lot of bare metal and so on, and a lot of rebooting and so on of physical servers. I mean, have you guys ventured into using Salt to kind of control the physical side of things?
So there's kind of like a talk about that, and I'm gonna have my butt in that room for sure. So like today, we are not in. Our team is very small. And we're trying to be like bacteria, slowly spreading Salt into the rest of our organization. So honestly, I talk about it all the time, we're trying to back Salt into these different areas. Supportability, what we're doing operation is kind of like bread and butter of the core part, but you absolutely can. I'm talking to the VMware manager every day, and our IT guys every day, look at what we can do. Let me just take a little bit more off your plate. And it's definitely with the POC stuff. They do a lot of manual provisioning for that. Just let me provision the drives. Let me install SQL Server. Let me do this for you so you don't have to do it anymore. So definitely. we're getting there, right? That's the whole thing. It's a legacy environment, right? Like, you know, we're just slowly spreading that infection. So, sure. Oh, get the microphone.
That's great. Oh, thanks. How do you manage the Salt code itself
So,
and the environment if it's more than
well,
one
you've got a
master?
slide for that.
Oh, wow.
You go ahead. This is yours.
Well, okay, so this architecture is, you know, it's probably pretty standard, but Rob helped us design this. We do have a GitLab server for storing version changes. Like Jim said, we are in charge of change control as well. So as we start to see, our environment is constantly changing, even as we're trying to automate it, right? So we're trying to adapt to variables that we can't take anything for granted, right? And things that you think may be constants may change tomorrow, and we didn't anticipate it, right? So we have to be very, very modular and use a lot of inheritance. And so we have this version control system that we're using to sort of try to standardize that, if that addresses your question. Okay.
So I see GitLab. I mean, do you guys have any kind of CI type, like testing and so on? I mean, do you use any of the GitLab?
Not yet.
Okay.
Right. You know, so I mean, Rob entered our lives December of last year, right? So, yeah, that's really when this initiative kicked off, right? So, yeah, I mean, our roadmap is like, you know, they talked about earlier, the IBM guys talking, you know, like 8.5 years of technical debt. Like, that's very real and near to me right now. It's like far like where we want to go. And we also have other mouths to feed, right? Like, it's not just about us, right? Like, POC deployment isn't about us, right? That's about our sales organization. But we have a lot of mouths to feed as far as that stuff's going on. But yeah, there's a whole lot of stuff, you know, cutting down the number of admins in the system. That's exactly the same thing we have here. Once we can do CI/CD in our system, we don't need to have so many people accessing the system. Once we can get reactors put in place, we can cut out some of the support resources. It's all there, right? We're just not there yet. Maybe next year we'll come back and we'll have something new for you guys.
Kind of a related question. You said this has been up for 6 months and you have about an 8-week patch cycle. So maybe 3 patch cycles so far since you've been up. Is that kind of accurate? I'm just curious how, between each cycle, how much better are you getting? Does that make sense? And is that delta accelerating?
Oh, definitely is. So, and also the thing is, of course, the first couple times we had to backstop it with the old process, right? So initially we have this situation where you have, you know, 20 people sitting around on a Saturday afternoon waiting for us to reboot all the systems, right? That's not fun, right? And especially the first time we're running into little hiccups here and there, right? So I think we probably went from taking, all said and done, 10 hours to do this just from Salt. We're down to, I mean, to do the UK, I'm done in 30 minutes. That's the whole thing, right? So like Friday night, everyone's done at 9 o'clock. We would go to 3 in the morning sometimes before, right? And then before you know it, you're butting into the U.S. stuff all over again. So, and our U.S. stuff went from probably 6 hours, it's down to, I would say, maybe 2.5 now. And like you said, every time as we find new stuff, right, finding new ways to gain efficiencies in the environment, that's what it's all about for us, for sure. Anybody else? All right. Yeah?
Oh, yeah.
What were some of the big showstoppers you may have hit? Either problems with, like we're deploying Salt right now, we're hitting issues with the Salt minions, and we've had to go for a couple months. What was your big hurdle you had to get over?
Definitely our biggest hurdle is performance between the grid system servers responding back, right? So what was happening with the orchestration states, when we didn't run an orchestration state, was the job would get like, I don't know, 30% done and then bomb, right? Because what would happen is it would run into a bunch of servers that just weren't responding, it would time out, and that'd be the end. So Rob and Kevin showed us this ability to create this kind of orchestration thing and increasing that timeout. That was our biggest show. The other one was simply deploying Salt, frankly. Like, you know, if you don't have any remote management, like, guess what? Same as Logstash, had to go and install it everywhere. So, you know, we've upgraded the minions a couple of times now, and just being able to do it in Salt is like, it's a whole, you know, it's like Shangri-La out there, right? It's like, it's totally different, right? It's changed how people view managing our environment, you know, radically, very radically. Thanks, guys, for all the great questions. I appreciate it.
Anything else? Any other questions before we end a little early? I'll say, since we are a little early, take the time right now, pull out your phone, rate the session before you leave. That would we'd greatly appreciate it. Thank you.
Thanks, guys. Appreciate it.
Thank you.